Hello, good to see you again. And this time we shall be looking at some extras to feel that you can learn. And we're going to be looking at um, what about when there's no data? What do we do when there's no data? That this time we're going to be making data that have never existed. For example, if you see this line, rows 500, real, false, useful is true, but the output is data that you have built and the assumption you have built into it. So let's dive in. So the plot twist, actually, you've done this. If you notice as is on part four, is it part four, or part three of the machine learning series? Actually, I've done it when the thread caster has a problem. One class had far fewer rows than the others, so you run smooth to balance it. Nobody explained what smooth actually did. What you thought was that you balanced the data set. What happened was that you invented some rows, not copies. You invented some new rows, new examples that never existed before. You have actually been generating state data since actually from I think Wednesday. That is actually part is it part three or part four of the machine learning series. You just did not have a name for it. So today we're going to do that on purpose. So when we say synthetic data, what does it mean? Data made by a computer instead of collecting it from real world. So it's not fake, but what you use computer to generate rather than going to feed to have it. So it's not fake, but it's manufactured like a flight simulator, like the pilot that's not flying a real plane, but the simulator behaves enough like one that the training count. So why will anyone try to make data on purpose, or why will anyone be looking for synthetic data set? Because of privacy. For instance, we're based in the UK. Hospital record, bank transaction, and school files cannot be shared ever. Nobody share it. A synthetic twin will help keep the pattern when you have it and throw away the people. Nobody will hand over nobody will add to a 60-year-old old person a real patient record. Synthetic one who does that. We have a state one able to all of that. Scarcity. The penguins were 303 rows. That is tiny. Rare event Ariara steal, fraud, equipment failure, a one in 50-year flood. You cannot wait for more data. You can simulate more. Build and test. When you have set data, you're able to build the whole pipeline before the data arrives. You're able to test the edge cases you hope never happen, and you balance a loop-sided data set. That is smooth. What we did to look at it, I think part three or part four, all of that. And what that's easy to miss, and then the data lets you check whether the model can find a pattern you know is there. If it cannot find a rule, you plant it yourself. The problem is not your model, but not the world. All of that. So when we say static data, is the one you build yourself, and it's not fake. Now, have they used synthetic data sets in real world? I will just quickly show you where they use that data set. If you look at simulacrum, the base in the UK, they use that for cancer, cancer record in imitating NHS England data. Researchers write their entire analysis on it, then have that code run on the real record. What about other examples? Cynthia, based in the US for health again, Mitra built over a million synthetic residents of Massachusetts data set, Massachusetts area, each simulated from birth to death, fully open source, used by government and industry. SLS plus and MHRA, based in Scotland, UK, the Scottish Longitudinal Study and the UK Medicine Regulator both release synthetic extras so researchers can work on them before they are trusted before the real thing. So Duo, that is in Netherlands, the Duo Education agency publish synthetic versions of national education data. Industry everywhere, self-driving car test on far more simulated minds than real ones. Bank generate fake fraud because real fraud is rare and computational. So yeah, so even this month, okay, last month, Swansea University advertised a job title synthetic data scientist. This is a career now, not a trick, and that's one of the things why we're exposing you to it. So we're going to try something very now. Look at it now. We're going to make data using these 8 lines of Python, and as usual, we're always using Google Colab. So you're going to see. I'm just going to copy this stuff. I have my because we are recording. I have my Google Colab open. I'll just come here, paste it here, I will run it. Let's see what's going to give me. I will run it. Let's see. Okay, I've run it. What's going on? I've run it, so uh, let me check. Check. Come in just for. Uh, okay, I'm supposed to press the head. All of that. Sorry. Yeah. So yeah. So after running it, right? So let me just press next code. Sorry. Let's see what's going to be there. So you see, yeah. So you see, just synthetic tissue wave have all of that. If I come here again, is there maybe df does info of data? If I just press here, it will give me all of that. Then if I also come here and df dot describe uh, all of that, so what's going to give me? So count number of so we just this using these lines, number is 200, round all of that, this and this, it give us all of that. Go back to our slide. So what have we just decided? Study helps. It decided that 5 marks per hour. It decided that too. Average student studies 5 hours, your choice. Nobody score below 0 and above 100. That's this part. Sensible but still your rule. And the noise that real people do not obey rules exactly. Some study for 4 hours, some study for 4 hours and ace it, some study 8 and have a bad day. So that's how you can use actually a simple line of code using Python stuff to generate stuff. So let's move. Yeah. If you notice, our model on the three score 96%. Why is that worthless? We train a decision tree on the data we just generated, and it scored beautifully. We sit with that for a second before we celebrate. Because we wrote the rule, the model did not discover that study helps. We planted it and congratulated the model for digging it up. What that 6% means here is that my generator is consistent. My generator is actually what? Consistent, and then that's all. It is actually what? It's actually a test of my own code, not a discovery about the student. The only real test here is that we give the real student data tomorrow. The real world never agreed to our rule. This is where the honest number was numbers. Uh, this is where the honest where the yeah. So let's move on. No, when you do not know the rule itself, what do we do? The honest problem with level one that you've entered relationship. What if you are wrong? Better idea, take real data, let it teach you its own patterns, then generate new rules that obey those patterns. First, you look how is each column distributed. Bell curve, skewed, count or categories. Secondly, learn how do columns move together. Does score rise with hours? Does one category always pair with another? Sample. You now draw a new rows that keep both the shape and relationship in contact. New people, new behavior. So those are part of way to. Then smooth is the simplest version of this. You pick a real role, find the what nearest neighbors, place a new point somewhere between them. SB does the full version and all of that. So you are capturing not only the rows now, you capture the structure, but you never copy and repaste to your output. All of that. So a lot of things that you normally use for we're going to use for static type for justice class, NumPy and Panda, which are the rule that we put in Python, Claude, which I used a little bit that time to check, Faker, realistic names that you can use, which I don't read, just put it there. Smooth, one job where to help you to balance stuff when it's in balance, SDV to learn the table, Cynthia Sims whole world that is simulate an entire domain and record what happens, no source data needed. GANs or LLMs, that is the machinery behind AI image and text generation, most powerful but least visibility. So going down the ladder, you gain more power and lose sight of your assumption. That trade is the whole topic. So now let's do something now. Ask for the recipe, not the meal. So I'm going to copy this into. I'm going to copy this. Uh, give me want to copy. Give me Give me 200 rows of songs as CSV. So I will just copy. If I copy this to yeah, yeah, let me just copy it here. Let me go back to a clean stuff. Uh, for You see, it can give me. If you want to just generate stuff, I'm just asking Claude. Let's see what it's going to give me. I hope you're enjoying the class. Uh, so you can use Claude, all of those AI stuff to generate a data set, and you see what's going to give us now. Because we said, give me 20 rows of song data as CSV. We even control it to tell us what we are looking for. All of that. As I'm waiting for that, yeah, I'm just checking time. It's still loading. It says device synthetic song dataset with collected features. It's going to generate script for 200. So, you know what he did? He just gave me a code that I can run. Okay. He's running the code behind. It's not going to generate this stuff. Yeah, that's all. So, this is it. This is everything. It has generated it. If you look at it, track ID, title, all of that. It says tracks it, 200 rows of song data as yes. So it's that. So if I want to do that, I will just download like this and data is there. So that's one way. Let's go back. So you get 200 rows. You cannot make 2,000. You cannot see the rule. So you cannot change it. Different every time, not reproducible. Claude quietly chooses the assumption for you. You will never see them. Now let's go to this place. Write a Python where, so now write a Python to generate song data where now we're now going to do write a generate. So let's see. Um, Python to generate. You get. I can say write Python to generate songs uh, related to, let's say, uh, gospel songs of who now? Let's say to see Oyeko in CSV. Let's see. That's a Python. It's going to be looking for the Oyeko songs. It's going to be looking for all of that. So after that, let's see what's it doing. Hmm. You see, he said, this is a real artist, so this splits into two parts. The catalog fact, titles, album years, which I can't reliably supply from memory, and derived audio metadata, which is synthetic either way. The script keeps them separate so you can verify one and trust the other one is clearly labeled. Should be done by now. Okay. So if I download this, uh, this is the Python stuff. Uh, I say, can I see the Pythons that so that I can copy and paste in Google Colab? Oh, that's the coding. Sorry. Oh, it's even here. You see, you can see it here. Yeah, it has done that. So now I want to now copy all of this. You see, even though this is not even like synthetic, but let's see. Let's see what's going to give us. We have to. But while we're waiting for that, these are all the songs that are generated. It has everything here. It should be true. So I'll just copy this guy. I'll just copy this. Come here and take it here. We're still using that stuff. And we're supposed to have named this place, but just run it. See this? It has generated every 200 rows. Track, all of that. So, future, so we can as well clean this one to work on it. So that's just an example. So now let's go to the next slide. Now let us a prompt that actually work. Write a Python using NumPy, and pandas that generate 500 songs with this. A song is a hit, all of that, all of that. So what will I do? I'll just I'll just copy all of this like a prompt. Want to just come here and paste it here in here and press. It will take time. So while we're waiting for it, I just feel like let's go. So 5 things to always specify. You need to specify the columns, name, relationship between them, the noise, always the noise, class balance if it matters, a random seed so it is reproducible. So that's what we see. We let them know the number of columns that we're looking for. Let them know the relationship. These are all of that. All of those things are here. So you can dictate. Since you have access to read data self, you can describe the kind of data you want. Like for instance, if you're in healthcare and you need diabetics data set, through what you know about diabetes, you can describe it and say you are looking for data set about diabetes that have this, it will give it to you. For instance, if you work as a hydrogeology and you don't have water quality data set for a place, you can describe that. Oh, give me, can you generate for me water table quality parameters, CL, all of that, CL, NO3, iron, all of that for a place like Lagos, for a place like England, it will generate it, and so that you can use that to work. And so yeah, first. So let me copy this. I hope you guys are following me. I'll click here, click the edge here, click so then run it. Let's see what's going to give. So it has done it. And if I want to now DF, uh, yeah, that's it. It has done it. You see, it has given me all of that. So I hope everybody is following. So next slide. So 8 sectors, 8 lessons hidden inside. Music lab, you can hit or flop tempo and energy. Teaches you better the label. Player plus for games, match day for sport, and all that. Every sector is same skill when different cloth. Pick the one you care most and all of that. So you can use this one to play with time. So now let's see this one. Well, I'm going to copy this. I'll take it to all of that. And yeah, so yeah, we want to ask train edition tree what accuracy. Now check the option it's just predicting flop every time. Remove the noise, all of that, and all of that. So let me just quickly copy this because of our time. Uh, I can as well come here. Um, Again, just I want you to let's see. Ah, so I can also copy it as well. What should I type next? I'm checking our time. Um, So you the day of learning coding back to back is gone. You can use this tool to able to teach yourself and all of that. So I'm checking time. Okay, why is still because of time? So three ways is that data will betray you. It's not giving new knowledge. New knowledge it can only contain patterns you or yourself that your source data put in. It can generate a million static patients and you have learned exactly zero new fact about medicine. It's a mirror, not a window. It has own bias and amplifier. If your read data or represent a group, your study data will do that, except you corrected it. Only now there's more of it and it looks official. Garbage in, garbage out, it has scaled, the same thing. Generate before you split, and the test set bleed into training through the generator. Your model has seen the exam paper again, you split it first and generate training half all of them. So let's check whether all of that. So your code runs fine, all of that, the training, all of that. So next step that matters. So I'll just copy this. Yeah, I'll just copy this, run it. What is it going to show? Yeah, you see, it's all of that. So again, this is just to expose us to that because of time. So eating the assumption you smuggle in yourself. On the four, you learn to move three for everything in your head. Ask, do I know this or do I rate it? Snare data is the purest version of that exercise because here you don't edit any assumption, you choose them. Every study data set is an argument about how the world works, written in numbers instead of sentences. The music example audited energy and disability make a hit. Do I know that or did I inherit it from a streaming chart? 20% of songs are hits. Where did 20 come from? I invented it. Tempo does not matter. I never even tasted it. I just left it out. So why it matters tomorrow, a judge can ask you where did the data come from? Agenda is the fine answer. So I generated it and yeah, the three association build it and yes, which one I think is okay. So you should be able to, when you use the data set, you should be able to talk about the bias and the assumption that come with it. And sometimes you can use this thing to build a portfolio actually. Anyone can generate numbers, knowing what to smuggle into them is a skill. Yeah. So the challenge I'm going to give you all of you, generate a static data set for a problem you actually care about. Pick any sector from slide 11 or invent your own. Rows minimum of 50, columns 3. Look at relationship, define relationship between those columns. Look at how they always be noise. See that is to run the same twice. Then answer one question in your notebook. What assumption did you build to your data that might be wrong? You need to look at that. Same rules as part of the machine learning stuff I've taught you. If Claude helps, make sure that you log the prompt. Be ready to defend every line, include the lines that you vetted yourself. So if you have done that, just email us about whatever you have done. So synthetic data is just a mirror, not a window. It shows you what you already believe in and any skill you have asked for. So the only question worth asking, what actually do you usually believe? And I only hope that you guys have enjoyed this intro to synthetic data set. Thank you.